All righty, folks. Hello and welcome, everybody. It is Monday, June 9th, and we are here to kick off our Cyber Rush Week series. Tonight is my pleasure to introduce our guest speaker. And before I get there, I will share a couple of announcements and reminders for those of you that are hacking away at our competitive CTF. A couple of notes. Number one, we did push out our competitive CTF challenges just earlier today. That went live at noon Eastern time to complement all of the beginners game room challenges that went live on Friday of last week. So if you haven't already done so, feel free to jump into Discord, jump into our CTF platform, and take a look at some of those challenges. Folks, my name is Brad Wolfenden. I'm the Director of Cyber Sports here at Cat's Eye Play Cyber. As we launch tonight, I just want to thank you all for all of your participation, all of your engagement. It's been so much fun over the weekend and throughout last week as we've kicked off our Season 5 anniversary campaign. Really just seeing all of you dive right in head first, take this thing by the horns, and have some fun. Continuing on with some of the reminders, here with the US Cyber Games program, we are very bullish on creating a community that is inclusive, that is welcoming, and that is respectful. And so while most of you have been competing with phenomenal sportsmanship and sportswomanship, there have been a few instances where we've shared some reminders for you all to review the rules, ensure that you are communicating on Discord and participating in the CTF in compliance with the rules that have been posted. So please take a quick look at those if you haven't already done so. In fact, the rules page on the CTF platform includes a flag. It'll earn you some points. It's a great way to kind of break the seal there, earn your first 100, and find yourself on the leaderboard. The last two announcements that I have to make. Number one is both the beginners game room CTF as well as the competitive CTF will stay available and live to you all until 11:59 p.m. Eastern time on Wednesday, June 18th. So you have just over a week to continue hacking, continue scoring points, continue running up the leaderboard, as we wrap things up next week on Wednesday, the 18th, we will be announcing winners the very next day, Thursday, the 19th. All of the prize information has also been shared via Discord. My very last reminder is for those of you that are interested in pursuing a spot on either the US Cyber Team or the US Women's Cyber Team. The competitive CTF is one of the eligibility requirements in terms of becoming eligible for selection for either or both of those teams. So make sure that you're competing there, and as you're competing, there is an application, which is another eligibility requirement for us to kind of move you into the next phase, review your CTF results, get to know you a little bit better through your application, and so on and so forth. So those applications are due at the very same time as when the CTF ends. That's Wednesday, June 18th, and you can find those at apply.uscybergames.com. I'll drop all of this information into Discord as reminders for you. And as I'm handing things over to Jason for tonight's talk, please engage with us via Discord. I'll be monitoring the chat and serving up some Q&A for Jason as we get towards the end of his presentation. And with that, I would like to welcome Mr. Jason Haddix to the fold. I know many of you know Jason. Many of you are fans of Jason. I've seen all kinds of wonderful chatter in Discord getting ready for tonight's presentation. Just a little fun fact about Jason I learned just a few minutes ago. His favorite category is web. So I'm sure there's lots to learn from Jason tonight. I won't steal any more of your time. Jason, it's a pleasure to have you tonight. Thank you so much for being here. Over to you, my man.
Awesome. Thanks for having me. I really appreciate it. And what an awesome kind of way to celebrate, kind of a night. I'm a former CTF player. I don't do it much anymore, but we were talking earlier about I used to play with Shellfish when it was part of UCSB, and Jan didn't split it between Arizona and California. So I was a good friend of Jan's on Shellfish and definitely did a lot of web exploitation as part of that group. So I love CTF. I've also been a big bug bounty hunter and kind of in this reconnaissance space or the topic we're going to talk about today. So super happy to be here. Hopefully some of these tips and tricks and tools and stuff. They can help you in the challenge. If not, they can help you when you get out there to testing, real enterprise applications as part of like a job as a pen tester or, doing bug bounty hunting or something like that. Um, so that's me. I've been doing, kind of professional hacking for about 20 years now, since I was 20. I am now the ripe old age of 40, which makes me a dinosaur in hacking, but I'm still pretty good at what I do, so I'm lucky. I run my own consultancy right now called Arcanum Information Security. If any of you are fantasy nerds, the name of the company, Arcanum, actually comes from a fantasy book called Name of the Wind, if you've ever read that book before. So we do a bunch of stuff. We do pen testing, we do AI assessment, we do, blue team assessment, you name it, we do it. But I've also done a couple of conference talks at DEF CON and Black Hat, and I think right now I'm ranked 67th all time on BugCrowd's bug bounty leaderboard. So I still participate in the bug bounty community a lot, and although I don't get to do it as much anymore now that I run my own company. So today we're going to talk about reconnaissance, and these slides are stolen straight out of my class. So I run a 2-day class called the Bug Hunters Methodology, and one day of it is hardcore reconnaissance, wide scope reconnaissance on organizations and how I target them when I start to break into them, which I call it recon like an adversary, but really I feel like a lot of the adversaries follow my methodology to target organizations. So it is recon like an adversary, but this is my methodology before it was anybody else's. So what I did is I took a whole bunch of content out of that 2-day course and put it into this new version of Recon Like an Adversary. So we're going to go over some tools, some techniques. It is not everything by far. To do a complete kind of reconnaissance assessment on an organization takes, there's a lot of methods. There's probably like, I think 14 methods that I run in the wide scope reconnaissance, and then a whole bunch more that I don't mention today in the on-app reconnaissance when you're looking at a web application. So we're gonna just choose some cherry-picked ones, but we'll go through, as we go. And if you guys have any questions, put them in the chat, and we'll try to get them answered. So pretty used to fielding student questions as we go. So the first section we're going to talk about is autonomous system numbers, so ASNs. So ASNs are logical groupings of IPs based on BGP routing. They are these 5-digit codes that represent a company when they get enough routed traffic, for the powers that be on the internet. And so when I'm looking at an organization and I'm looking to hack into them, I need to know every asset they own, because all I need to do is find one asset to break into to cause them a problem, especially when I'm doing a red team assessment or something like that. So in the beginning, in the beginning, we want to identify all owned servers, IP ranges, and domains for our targets. And so what we're going to do is we're going to start looking at their ASNs. So when I start reconnaissance, the first thing I do is I go to this site, bgp.he.net. This is Hurricane Electric Internet Services. They're one of the longtime BGP kind of companies that also keeps an up-to-date table of ASN numbers. So you can see here on their website, you can just put in a freeform search for any company name here. So here, if I'm going to hack Twitch, right, I can just put Twitch in here, and you can do a freeform search and find all autonomous system numbers that match that freeform search. And so here you can see that the company I'm looking at is Twitch, and they come up as Twitch Interactive as their ASN name. And then you can see that there's 2 codes right here, always prefixed by AS, and then either a 5-digit or 6-digit code right here. So this represents basically all of the owned IP space, not cloud IP space, but owned IP space of Twitch. And so on this website, you can go and click into these, and you can get your first set of targets when you're attacking an organization is everything that they own. So if you go do like this, I'm going to do some live labs. We can go in here and we can just search Twitch, and you can see Twitch Interactive. And if you go into here and you go to prefixes v4, this is their IPv4 space. It will load this. Here is all their owned IP ranges for Twitch Interactive, right? So this is the first place I go to understand what attack surface that Twitch has as a company, right? And so now I can take these IP ranges, and you all are doing challenges right now, which I'm guessing involve, some form of port scanning or service enumeration. And so this is the place where you start to get those addresses when you're attacking an organization. Now, one thing to remember about this, This is owned IP space by Twitch Interactive, but it does not represent their cloud IP space. And most organizations these days are hybrid, right? They have some owned IP space and then they have cloud IP space, which lives on the Amazon range. And so if you were to go to twitch.com and look at its IP address, it's probably going to live in one of Amazon's autonomous system numbers. It'll say like, AS whatever and then Amazon whatever. And that's because they run their website out of the cloud. But they do have plenty of owned infrastructure that they own themselves. And so these are the IP ranges for that. There are other methods to discover their cloud footprint, which I think I have in the deck today. So we will do that. So. Okay, so this is the first step in finding out kind of their footprint is looking up their ASNs. Now, sometimes you get kind of an outlier where you can't find an organization's ASNs because you don't have the right organization name. Like Twitch Interactive was easily a hit because we searched for Twitch, but one time we did basically a recon assessment for a conference, and someone from the State Department came to us and said, "Hey, like do the State Department," which reconnaissance is not a crime as long as you're not breaking into anything. And so we said, "Sure, we'll do the State Department live." Well, the statedepartment.gov website is hosted in Amazon. And so when you go look that up, when you look up state.gov, the website, we couldn't find anything in bgp.he.net. So there's a secondary site called DNS Checker that I use, and dnschecker.org will allow you to put in a domain name, and it'll show you all their records. And so when you're looking up an organization, it does kind of behoove you to look up all of their record types to try and find their owned IP space. So if you go to dnschecker.org and you basically search for state.gov, and make this big, you can see you get, again, their website, state.gov, has several A records that point to Amazon AS numbers here, autonomous system numbers, 165.509, 14618, 14618, right? So this doesn't help us because we want to find their owned system. Now, new companies in kind of the world, some of them will be cloud native and don't own any like, rented IP space or, their own, colos or data centers or whatever, right? So they may not have an ASN. It's not guaranteed that everybody has an ASN. But when you're thinking about a government entity like the State Department, I'm pretty sure that they have owned IP space. So if you use DNS Checker, you can scroll down here and look at their other records. And here are their quadruple A records, CNAMEs, and MXs. And then if you look at their MX records here, you can see that they do indeed have their own autonomous system number. It's 6966, and the name of it is Department of State. So now we know the name, and we can go back to Hurricane Electric. And then here is U.S. Department of State, 6966, and you go to prefixes v4, and hopefully we get their IP space. Yep, there it is right there. So this is kind of the way to find, the owned IP space of a target. This is very much what adversaries start with, right? So they want to break into any and all of these services that are exposed to the internet that have services on them, websites, remote administration protocols, all that kind of stuff. The last couple of years have been the years of web apps that control firewalls and network hardware. If you've been following, like kind of how most organizations are getting breached, it's breaking into these like really brittle web apps that control those technologies. So, all right. So this is a secondary site you can use to look at all records. You could also do this on the command line, right? But sometimes it's just easier to use like a browser tool like this, and you're not guaranteed to get that cross lookup of, here's all the records plus all the ASNs that they live in. So, so this is the first place we go to get information. Now, there's the idea that you could be an organization, and in this case, we're looking at T-Mobile here, and T-Mobile is, obviously a phone company or basically a cell phone provider, a cell provider company or whatever. And they have a bug bounty. And so when we were looking at T-Mobile and we were hacking them, um, you realize that these big companies, when you hack on them, they've had a lot of acquisitions, right? T-Mobile especially has had a ton of acquisitions of smaller companies, or they've spun out subsidiaries or something like that. And these things might be in scope for like a bug bounty when we're working on it, but also could be in scope well, definitely are in scope if you're a bad guy, right? You don't care about, any bug bounty rules when you're an actual adversary. So, one of the sites I use to see related ASNs is this asrank.kada.org site. And so you can put in the organization name here, T-Mobile, and you can search it and you can see all of the associated AS names that have ever been associated to them before by AS number or by routing peering or stuff like that. And so when we did this assessment, we went to this site and we were doing the bug bounty, and you could see that there were a couple acquisitions that I have, kind of with red in the screen, and we were able to understand that they had a subsidiary called T-Mobile Fiber or T-Fiber, in which had a whole bunch of IP space that we hadn't found before. And then Clearwire was an acquisition of theirs, and we were able to find a whole bunch of basically web infrastructure that hadn't been taken down from the clearwire.com domain. So this allowed us to find like kind of more esoteric but related infrastructure to hack for this bug bounty program, which did lead to bugs eventually, which was super cool. So this is another site I use when I'm doing reconnaissance, on a big company. Now, smaller companies, they might not have anything in this database. There might not be any related ASNs or anything like that. But for big enough companies, they will usually always have had some acquisitions or mergers or things like that. And so this is where we go to get that data. So when I'm doing these assessments, normally I run small projects in a mind map. So I use a program called Xmind. I don't know if any of you've heard of it. It is free for the, well, there's a free edition. And Xmind is just a mind mapping software. And so when I start grabbing this data, like the IP ranges from that search, I'll just dump them in a mind map hierarchy. And so here I have ASNs and all those IP addresses for Twitch that we the search on. And so as I get more and more target data, I'll dump it in here. The cool thing about Xmind is that also you can export this, this program that makes a mind map. You can export it to Markdown. So later on, you can grab it via Markdown if you'd like to too. So I'll just update my notes. Now, the next place I'm going when I'm attacking an organization is I'm going to use this tool called CheckMDI. And what CheckMDI does is it's a Python tool. And CheckMDI, basically, when you are an organization and you have employees go home to set up Outlook and their Microsoft services, you send a laptop to their house, especially if they're remote working, right? You send a laptop to their house and they start up the brand new laptop, and it has to connect to the Microsoft ecosystem for email, so Outlook. And 94% of the world, especially big organizations, use Windows as their operating system and Outlook in some capacity. Um, and so what exists online are this a set of APIs that Microsoft hosts called the Autodiscover service for those laptops to go and configure themselves and get the right email domain to let you log in and use your company's email. Now, these are open to the world, and red teamers, in the past couple of years have made some really good tools to interrogate these public APIs to get information. And this is the next place that I will go to get information about a target. So CheckMDI will basically reach out to these APIs and you give it a starting domain. Here we're looking at Tesla, right? So Tesla.com. And it'll tell you all of the other domains that Tesla manages in the Microsoft ecosystem. And it'll tell you their Microsoft tenant name. And so here we're running it on Tesla, and you can see that Tesla manages several email domains: Tesla.com, TeslaMotors.com, Perbix, which was an acquisition, Tesla.services, which is for their services group, a subdomain service.tesla.com, c.tesla.com, MTA. So these are subdomains that we found here. Cylon, which was another acquisition, Tesla Alerts, which is for their IT infrastructure. Tesla Grumman Engineering was an engineering acquisition for Tesla. And then Solar City is obviously, Solar City does like solar panels and stuff like that. So what this does is after we put in a domain like this, we get back a ton of new, what we call, in our methodology, apex domains like Perbix and Solar City. We might have started this assessment, or as an adversary, we may have started looking at Tesla and just thought that Tesla.com was our only target. Now we have significantly opened up our scope to more targets that we might be able to attack. And then we know their Microsoft tenant name too here, which is Tesla Motors Inc. So CheckMDI is an essential part of getting started, widening your scope in, a red team assessment, a pen test, a bug bounty hunt, stuff like that. So, so this is CheckMDI. Make it a little bit bigger for you. And we can just do -D and let's see. Let's just do Dell.com, see what comes back. Non-scripted. Okay. So it reaches out to those Autodiscover APIs and it pulls back Dell manages Dell.com, data domain, VCE, EMC, virus stream, 508 Wizard, Dell Team, Moogsoft, Isilon. And some of these are acquisitions and some of these are subdomains, and then some of these are um, websites that I think they host as well for other, I think, big customers. So this gives us a significant amount of more data. Um, let's check tmobile.com. So T-Mobile has a significant amount of domains as well. So T-Vision, T-Mo Events, which is their events portal, T-Mo Fiber, which we talked about. And so this significantly balloons the amount of attack surface we have as an adversary or as a red team or something like that. And then we know their tenant name for T-Mobile is T-Mobile USA. So check MDI, this script is one of the best kind of out of pocket tricks that we use to make our scope bigger. And the GitHub link for this Python script is down there. So. Next is okay, well, you have a whole bunch of domains now. You've widened how many domains you've had, and you have a whole bunch of IP space from that autonomous system number listing. Most hacking trainings or university classes will talk to you about, okay, well, let's start port scanning those using nmap. And when you get to starting to do really big assessments, you realize that nmap is slow, like super slow. And there are better port scanners to use. Now, empirically, RusScan is the fastest, which RusScan is a wrapper around MassScan, which is a kind of a raw TCP socket port scanner. Very fast, very extensible. And RusScan is a wrapper around that. But we don't necessarily need the fastest. We just need something that's fast and extensible. And so when you're doing big projects like big bug bounty programs or big red team assessments where you have a lot of IP space, um, I use a port scanner called Nabu by Project Discovery. It allows the balance between speed and just kind of extensibility. I think that is really good. Now, what Nabu will do is it will do a port scan, and it is just a port scan. If you've used Nmap before, you know that you get a lot out of Nmap. You get the service version scanning, you get the Nmap scripting, kind of library of checks, and it can do a lot of cool things. But when you're doing port scanning like this, you can use Nabu just to do the raw port scan and then take the output of that and pass it back into Nmap. And so that's why I like this workflow. It's much faster than just using raw Nmap. So here I have the ASN for my target here. And you can pipe it into another tool, and we're on the command line, right? So you can pipe it into another tool called ASN map, which just expands out the IP ranges. And then you pipe it into Nabu, the port scanner, and you can add the flag silent and nmap CLI, and then nmap-sv. So what this will do is it'll do the port scan quickly with Nabu across that ASN, and then only when it finds an open port will initiate the nmap service scan. And so this is a much faster workflow and cleaner workflow than you can get with just kind of like spending all your time waiting for nmap to finish or using mass-scan or RusScan and having to parse that output. This is what I use in real assessments, and it rides that line of kind of speed and extensibility. So. Also, if I'm on a red team assessment, I don't want to tip off the blue team that I'm hitting them with, scanners, port scanners or vulnerability scanners or anything like that, right? So, many of you have probably already heard of Shodan, right? And Shodan is an infrastructure spider that lives on the internet. There is a tool called SMAP, which basically has the exact same syntax as Nmap, and you can use it on a domain or an IP, and it'll go out to Shodan and pull Shodan scrape data. So if I want to do, if I want to know just off the top of my head what ports might be open on a certain target, I will start with SMAP because this will go to Shodan, pull that data back, and I'm actually not touching my target. So there's no way they're going to detect me. I can get some preliminary data from this tool SMAP without ever touching my target. So in red teaming, it comes in really handy. Now in a CTF, there might not be any locator of IP, IP data in Shodan, so you might not get anything back. But for real world, like websites that are on the internet or domains or IP space on the internet, this tool, Shodan will usually have crawled it at one point or another. Okay. So the next section I pulled out of the class was Cloud Recon. So we talked about how a company can have like they own this IP space because they have a data center, et cetera, or they lease that space from someone else, whatever. And that'll show up in their ASN, right? But many companies are hybrid. And when you're attacking them, a majority of their infrastructure lives in the cloud. And so like how do you find an organization's cloud footprint like completely? So what we're going to be doing is analyzing SSL certificates to find the domain of our target or our customer or our bug bounty target, whatever, right? And so we're going to use SSL certificate data to do this, and I'll show you how that works right now. So why are we using SSL certificates, right? Well, most of the time, what we're looking for in bug hunting or adversary work is websites. They're, the first to fall over, and sometimes domains too that are associated, with other services on them, right? And so, the biggest kind of place that we can grab domain information is SSL certificates. And so, if you've ever looked at the metadata of an SSL certificate, you know that there's several metadata fields or just fields in general. They're not actually metadata, but you have the common name. And then you have a couple other places that have domain information in them. So you have an organization name, and then you have a subject alt name. And so you can see here when you go to a certificate and you go into the metadata field, certificate subject alt name, you can see there's a whole bunch of other DNS names associated to the certificate we're looking at here, Nike. You can see that there's a whole bunch of subdomains, so Nike team.nike, web.nike, community impact, and there'll be other top level domains in this listing too if they're sharing a certificate. So how does this help us find our target's cloud infrastructure? Well, what we're going to do is we're going to we're going to go to basically all of Amazon's IPs that they have, the entire Amazon IP ranges, which is published online. They have to legally. And we're going to scan them all at the IP level and ask for the SSL cert. Then we're going to look at those three metadata fields. And if they match our target's domain, then we're going to alert and say, hey, our target domain lives on this IP address. Now, this is not foolproof, but it is very good proof. I don't know what the opposite I was looking there, right? But you can scan a whole hosting provider's IP ranges and then look at all the cert fields to get a good feeling for what they're hosting on the cloud and where they are in a cloud. So where do you get these IP ranges? Well, they're published by each hosting provider. So this is Amazon's reachability page for just EC2. Now you can get their full IP ranges other places, but this is just a visual I like to show. This is all published online, right? So you can grab this information anywhere and you can grab the IP ranges. And you might be looking at some of these ranges like /11, /12, 14, 16. These are massive amounts of IPs. And so scanning them, you'd be like, well, that takes a long time. And you'd be right, it does take a long time. But today we have better technology than we've ever had to do this type of scanning across large IP ranges for just this one thing, SSL certificates. So first you got to go get the IP ranges. So there's this repo out there by this researcher called Lord Alfred, and he just goes out and he collects those IP ranges from the different hosting providers. So you can see he has Amazon, Bing, Cloudflare, DigitalOcean, Facebook, GitHub, Google. He's got, all the big cloud vendors, all the big kind of service providers. And he has just one file in his repo called all/IPv4 merged. And it's basically all of their IP ranges. So if you wanted to get all of them, you can grab them, or you can just focus in on Amazon or the Microsoft, cloud ecosystem, Azure, or whatever you want. So you get the IP ranges from a repo like this. Then you use a tool like Caduceus. So Caduceus is a SSL, basically an SSL certificate scanner that's meant to rip through IPs at an insane speed. And so my friend Golden, his real name's Gunnar, he wrote this tool a couple years ago for our bug bounty kind of group. And basically what it does is takes an input, a CIDR range, and goes out to each IP on the port or on the IP level, looking for an SSL cert, looks for and then basically just rips out the all of those three metadata fields we were looking for, and just outputs it to a line in a file, or it can output it to a database. If you script that up really well. Now, the reason Caduceus is really good for this is it has logic in it very similar to maybe if you've learned about port scanning and Nmap and how some of the different probes work. If you've learned about like the half scan in Nmap and how like you don't complete a full TCP three-way handshake, very similar in Caduceus, we don't complete the full SSL certificate transfer. We just get the metadata and then move on to the next IP. So it is significantly faster, about 10 times faster than using a standard port scanner. Plus, it's only looking for one port, 443, although you can extend it to look for other ports. And so what you do is you feed those IP ranges that we found in the last repo to Caduceus, and you can scan a whole cloud range like Amazon in about 2.5 days and build your own database of everything that Amazon hosts. And then you'll have a database of that, and then you can just parse it however you'd like, regex, grep, or whatever to find your target. And so if in our case, our target was Tesla, you can just search for, tesla.com in either the database or the output file that it creates for Cloud Recon. And so then you get a full feeling of where your target is hosted in the different clouds. Now, if you don't want to do that, there's some other options as well. There's a hacker group and a bug bounty group called Käferjäger, and Käferjäger does this for you at that URL, and they just allow you to download the file, so you don't have to do the scan yourself. Now, if you go to Käferjäger, every once in a while it's down. Also, if you go into any of these, you'll see the dates. They'll look like, they haven't updated this in a long time, right? And you want fresh data when you're attacking an organization. You don't want stale data. But these actually are not right. If you dig into these folders, you just click into here, you'll see the last time they did a scan. Usually they do a scan every month of the big cloud providers, and you can just download these files and then grep them. So you don't have to do this, the Caduceus scan yourself, although I usually do. 4 weeks is, somewhat stale data for a bug bounty hunter like me. I need to know, up to the day sometimes when a new cloud asset shows up for a target that I'm doing bug bounty work on, right? I want to be the first one to know about it, the first one to hack it. And so many hunters in the bug bounty scene have automation that's running, things like Caduceus in the previous slide continually and alerting them when a new domain is found. Okay, so you want to do a point in time scan of the entire cloud, but then you also want to keep up to date, like I'm saying, when a new domain comes out in the cloud. And so another tool that Gunnar wrote is called Gungnir. And what Gungnir does is it basically watches all the certificate transparency projects and logs out there on the internet for a certain domain. And it does this better than any other tool out there. So it'll basically watch these registries, and anytime a company registers a new domain, a new domain SSL certificate, it will show up on a command line with this command line tool. And so we hook this up to give us Discord alerts when it finds something new. So, if I grab Discord right here and I go to my hacker let's see here, go to my hacker channel. I'll show you kind of what that looks like. Do, 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 do. Oh boy, here we go, hunt announcement. Okay, so right now in my Discord for bug bounty hunting, this is Gungnir, and we have a couple programs we're working on right now. We're working on AT&T as a bug bounty, and we're working at Epic Games. And you can see just the well, I don't know why it says March 11th. Oh, we stopped running it. So we stopped running Gungnir in this channel right now, but this is what it looks like. So we just have it send a Discord message with a tool that we extended called Notify, and it will tell us anytime a new SSL cert has come up, and then what the status code of that server is if we go out and try to visit it. So this is the kind of automation you can get. And when we see a new asset drop on here, we will go check it out. Like item shop storybook, ddcf.dev. It's a long list of subdomain, nested subdomains. But this is interesting, right? Because it's a dev server. You can see .dev. Got something to do with an item shop in one of their games. So So yeah, so getting this just-in-time data is really valuable for looking at organizations and being the first one to attack them, basically. Okay, so when you get that ASN data, you can also just instead of doing full port scans on all that stuff, you can just give those IP ranges just to Caduceus because they'll scan any IP range. It doesn't have to be the cloud IP range, or and you can put it into there and then just get an idea of what they have as far as servers that run on 4.4, like web servers that run on 4.4.3, and then also what's in their certificates. So this is a quick thing also for internal pen testing, or for those of you, I don't know what the challenges are like, but in attack defense CTFs, I don't know what the structure is, but a lot of times blue teams, when you're doing an internal pen test or you get on the internal network, you want to start probing the internal network. But if you fire off, mass scan or any of the port scanners, they'll be picked up by SOC tools. If you use Caduceus and you're just doing this half SSL scanning just to look for websites you might want to plunder, this flies under the radar of a lot of SOC analysts because it's just web traffic. And so they just can't, in an organization, everybody's throwing wet net, 443 traffic everywhere. So this one is one we use on internal pen tests and internal red teams when we get on there because we can get a good feel for mapping out the internal like web assets of an organization after initial access, after we get access to the internal network. Okay, so another kind of thing that's one of the main components of doing wide-scale recon on an organization is subdomain scraping. I'm sure some of you, have done this before, but we're going to talk about, a couple tips in, this kind of realm. So subdomain scraping will be the biggest contributor to, we found all of these top-level domains. Now we need to find all their subdomains. And for every top-level domain, there's usually somewhere between 2 and 30 subdomains for an Apex, for a top level domain. People don't just register top level domains for nothing, right? Usually it's a new brand or it's an acquisition or something like that. And so you're going to find a bunch of subdomains which each represent usually a web asset or an asset of some sort that has services on it. And so you want to find all of these subdomains while you're attacking an organization. So before, all we had to do this was basically brute force, which sucked. It took forever. And then, several years ago, a tool came out called Sublister, which introduced this idea of scraping this information from a whole bunch of different data sources on the web. So things like the Wayback Machine, DNSDB search, passive total, cert.sh, cert.db, search engines like Yahoo and Google, even security sites that give out IP information like Virus Total, Security Trails, all these kinds of things. And so Sublister was a command line tool that would go out to these places and say, have you seen any subdomains for Tesla.com? And they would say, yes, we've seen several subdomains for Tesla.com. Here they are. And Sublister would bring that all back to you. Now, that was the first tool of its kind to do that and revolutionized the idea of scraping the web to find subdomains. Now there are several more that are way, way better. This is just the idea of subdomain scraping using Google, right? So you can just use search operators if you wanted to do this manually, but many tools automate this. But if you wanted to do it manually, you could use search operators. So you could say site colon Twitch TV, and then once you found some subdomains like www, watch, or dev, you just minus them out with the minus operator. And you do this recursively until you get no more results. And then you will have a complete list of all subdomains that you can find off of Google for twitch.tv. Now, the new school stuff is Subfinder, again, by Project Discovery. They make a lot of open source tools. If you haven't used any of their tools, you should check them out. Nuclei, Subfinder, a whole bunch of other ones. Subfinder is the new. Now, Subfinder will go out and scrape, I think, somewhere in the neighborhood of maybe 40 or 50 sources at the moment. And the game here, if you're a bug bounty hunter at least, is finding the most subdomains you can so you have the better chance of breaking into an organization or finding a bounty, especially in wide scope projects. Now, Subfinder comes by default, and everybody's using it by default, on assets. And so here you can see running it on twitch.com and, giving back a whole bunch of subdomains for twitch.com. But there are some pro tips when using Subfinder. There's also another tool that lives in this world called Amass, written by Jeff Foley. I have mostly stuck with Subfinder because the newer versions of Amass kind of they have ballooned in scope and what they're trying to do with the Amass tool. So I put it in the slides, but I use mostly now exclusively Subfinder, and a couple other ones that aren't in these slides. But if you find me after, I can tell you kind of some of the other stuff that's super dope. This is a quick guide for Amass because they changed it. Most people have been using Amass, and then they changed Amass and they split it into two tools. And so this is just a quick refresher guide on 4.0 on like how to use it. But again, the only thing about Amass that I still sometimes use, and I use it for clients to give them visibility as to like where their subdomains and domains resolve to and where their infrastructure is this table right here. So Amass generates this table, which I think it is still worth to have in kind of my tool belt. So when you run Amass, it'll find all the subdomains for you, but then after it does that, it'll print out this command line table, and it'll say, "Hey, we found 439, subdomains, and they map to these ASNs." And so this is usually useful in a consulting engagement, not really in a, CTF or bug bounty, but it'll map the IPs that it found, or it'll take the subdomains and domains it finds, and then it'll reverse them to IP addresses and then tell you what ASNs those live in. And so you can get this idea of like, okay, so I ran this on twitch.tv or twitch.com. And you can see, okay, well, a lot of their IP address, a lot of their stuff is hosted in the cloud in Amazon, right? But they also have their own, a lot of it's also hosted in their own ASN, which is called Justin TV. And if you ever followed Twitch, you know that it started as a company called Justin TV and then later rebranded into Twitch, and then later got bought by Amazon, which is why so much of its infrastructure is also in the Amazon ranges here. You can see they also use Fastly for part of their tech stack. Bitly. They have one server in Google. They use SendGrid for mail. They have 8 sites located in the Japan region of AWS, and then we actually found 66 privately resolving IP address. So this table is usually useful for customers because they'll be like, "Oh crap, I thought we completely got rid of all of our Google stuff." So I provide it as like a, kind of like, hey, just for your visibility type thing. So that's why Amass is still kind of useful. There are some other tools that scrape different sources than Subfinder. BBOT is one that I like, and they scrape like the 2 or 3 sources that Subfinder does not. And so I will use them in conjunction. It doesn't hurt me to kick off these tools at the same time. It's just a command line run, bbot-m otx-t tesla.com. And then basically cat the output to a file and unique both tools output, right? Doesn't hurt me at all to run more than one, like subdomain scraping tool. This is just some parsing, command line parsing just to get the output you need out of bbot, not really super important. But move into the subdomain scraping secrets. So when you're doing this workflow, subdomain scraping, you will have a whole bunch of output. But if you look at these tools, this is Amass, but Subfinder is exactly the same way. It'll tell you what sources it's using, but only some are available by default, and some require an API key for you to grab the subdomain data. So, like any of these APIs require you to register a free account and then provide the API key to the tool to get the best thing. And so, a lot of people, when they use these tools, they'll just use them out of the box. They will get output back, but you're missing about 28th percentile of the type of stuff you can find from them, which that's a big amount if you're doing, a red teaming assessment or a bug bounty hunt. So looking at the sources that they have, so a mass enum list will show you all the sources and which ones are available. And then going out to these sites that are not turned on and grabbing an API key and adding it to the API key file for these tools, and then getting that enabled will make your subdomain enumeration way better. Now, there are 3 sources you should hook these tools up with pretty much right away. They're the best priorities for these tools. The first one is this chaos data set by Project Discovery. Again, Project Discovery has been scanning the internet ever since their inception. And this data set, the chaos data set, is a giant DNS data set with a bunch of subdomains in it. You go to there, you register for a key, you get the key, and then you put it in Subfinder, and you get a lot more stuff back than normal. So this is priority number 1. Priority number 2 is a GitHub token. These tools have the ability to go out to GitHub and ask in the GitHub search right here, what do you know about, what subdomains do you know that are related to Tesla.com. There's a search syntax that you can use in the search bar on GitHub to ask that type of query. But in order to do that, you have to create an old personal access token. And so you have to go to github.com settings and tokens, and you have to make a burner account for GitHub, and then paste it into your tool like Subfinder's configuration file, and then it can go do this. This is priority number two. There are so many esoteric mentions of subdomains for organizations out there that are mentioned in GitHub data, just a ton. I have found so many obscure domains that I've hacked from this data set as well. So. The last is Shodan, which we kind of talked about. You can get a Shodan API key for pretty cheap usually. And Shodan is a vast data set. And it should be the third priority that you hooked up into the configuration file for one of these tools. There's other ones that you can get that are free or cheap. So Facebook Developers Program, you can search Facebook for mentions of domains or subdomains. C99 is another site, and DNS Dumpster. And then the paid limited sources, these are the types of things that the hardcore bug bounty hunters are using, and they cost money. Cisco Umbrella is a $20,000 a year transparency project for DNS data. DNSDB is kind of the same thing. Zetalytics, Security Trails. Security Trails is probably the cheapest, best one on this list because not a lot of people have access to these three top ones, followed by Spiderfoot and Netlist. All of these are DNS categorization and monitoring sites for one reason or another. And you can hook them up into your Subfinder configuration file. And like having something like these top three hooked up into your Subfinder output makes you more effective as a red team or a bug bounty hunter. I would say if I'm just ballparking off the top of my head, like by 8%, I think is the like kind of the increase in freshness you get from having these data sources hooked up to your enumeration. And that's a lot for someone who's doing full-time bug bounty hunting or doing a red team assessment. So all of these are put into config files. So this is an example of the config file for Subfinder. It's just like a small array here, and you put your API key on, a line, and it's pretty easy to set up. It's just a YAML file. So, okay. I talked about GitHub and how you can enumerate it for subdomains. You can also enumerate GitHub for just like a treasure trove of other stuff. Vulnerability data, secrets that are leaked that developers accidentally leak to personal repos. You can get an idea of your target's tech stack. And so really it behooves you to spend a lot of time on GitHub learning about your target and what's been disclosed. A lot of times people look at this type of vulnerability. What they are looking at is they want to look at or they think that you're just going to scan the company and the repos they own. I actually don't care about the repos most companies own. I actually want to know developers at the company who have accidentally committed corporate code to their personal repos. Those are the kind of things I'm looking for because more often than not, they will have leaked, like good juicy stuff in there. There are a couple tools to do this. One is get subdomains. So this one will basically allow you to specify a subdomain or a domain like Dell.com, and then you pass it your token. And then it'll go out and say, hey, Dell.com was mentioned in this repo. Dell.com was mentioned in this repo. And community Dell.com was mentioned in this repo. And so I use this to find subdomains, although Subfinder does this as well. This tool does it a little bit better. It paginates much better than Subfinder, yeah. But I also do this because it gives me the repo name. And if I see a specifically juicy kind of named subdomain here, I will go look at the repo and then start analyzing it for leaked creds, for leaked source code that I think is juicy or something like that. And so, something like configure.ap.dell.com would be something I would consider juicy, and I'd go check out this. Now, this is just a DNS mask list, so in that case, I wouldn't find anything great. But when you start looking at organizations and you put in some domains here, you'd be surprised what you can find on GitHub. You can do the idea of this GitHub dorking, just like we learned about Google dorking 10 years ago and using Google to find vulnerabilities. You can do this idea of GitHub dorking. I have my own script I run, and it just builds links. So I pass it a domain like twitch.tv, and it builds clickable links from my console that open GitHub and search for different keywords like password and twitch.tv.com or twitch.tv or npmrc_auth and twitch.tv. or pen private, or HT pass WD, or get credentials, or secret key, or API key. So here I'm looking for leaks of cred data for my target, and it has to also include the domain twitch.tv somewhere in the repo. And so this is the idea of GitHub dorking, and this is a giant list. If you're interested in getting into this, I posted my personal script here, and it grows all the time. Um, Once you get into this, you can also run code scanning or secret scanning tools right out of your browser. So I don't have a picture for it here. We added it recently, but Trufflehog has a Chrome extension, which if you land on a GitHub repo, and you're looking at it with your eyeballs, you can run this Chrome extension in the background. And anytime it sees a hard-coded cred in that source code, it'll just give you a pop-up and it'll be like, hey, it looks like there's a hard-coded cred here, which is really useful when you're looking at super large, super large files of code. So there's a ton of other things you can do with looking for things like text and DBMS types and open source components and CVEs in the GitHub kind of dorking world. There's a couple of really good other tools for general search, so GitHub search, and then there's a really great presentation, which I couldn't fit all in here, which is called GitHub and Sensitive Data Exposure by a bug bounty hunter named The Gentleman. So if you're interested in this topic, and you should be if you're a bug bounty hunter, that's a resource to check out. So I'm going to skip the story because we've got a lot of slides and I only have a few more minutes left. So, okay, so you've gathered a bunch of subdomains for a bunch of top level domains in the, and some cloud resources, right? Well, how do you prioritize attacking an organization? What do you go after? Well, the first thing that I do is pass all of those live sites that we've gotten to a screenshotting tool. And what this will do, there's several of these screenshotting tools. There's HTTPX can do it, GhostAir can do it. There's another one called Eyeballer. They're all just command line tools that you run that will go to a domain and attempt to take a screenshot and dump the screenshot in a folder. Or they'll make like a web page for you to scroll through to look at, right? And so this is the idea of, okay, so we have a lot of stuff and we need to narrow in on what we want to hack. Well, there's some stuff you can narrow in on, like sites that look like they were coded in the last decade, right? Because of their CSS styling, or login pages are places you want to look for default creds, or configuration or API pages or things like that. Some of these tools do that work for you. They'll actually categorize, like this one says old looking sites, login pages. It will do the screenshots and then categorize them for you. So Bishop Fox Eyeballer tool is one of the most popular screenshot tools that exist. And this will help you prioritize all of this recon data that we've been looking at so far. There's another one called Aquatone and Eyewitness. There's a ton of these tools. There's another, this is what it looks like when they dump all these screenshots to a folder. You don't need a fancy website that it builds for you. You can just look at the folder with thumbnails enabled and be like, cool, these two are identity providers, so I don't really care about that. Here is their Outlook email. This is the main Tesla site. This is the main Tesla site. This is a configuration and comparison site. So this one might be interesting because it might be a custom application. And this one is their shop page, which probably has been tested already. And these two I'm getting errors on, right? So you can prioritize just by looking at screenshots. Another one is Go Witness that a lot of people use. This is probably the second most used one is Go Witness. There's a great blog on it by Black Hills Information Security, the pen testing outfit. I don't know why the image is not rendering here, but it also builds you that kind of web page to analyze the results. The only reason I would go with anything other than those two is this is an OG tool, Eyewitness, one of the first ones to do this screenshotting thing. Eyewitness has like one feature that none of the other ones has like caught up with, even though it's super old. It actually has a small database of when it takes a screenshot and it sees it also grabs the HTML code for the page. And then it compares it to a database, and it has a little database of default credentials for a lot of normal like services or different type of infrastructure website logins. And so every once in a while, I'll use this, especially on internal pen tests or internal red teams. I'll use Eyewitness to take screenshots, and it'll be like, hey, check for default password this. And I have hit before, especially like on older networks like hospital networks or older finance networks, definitely found default creds. So that's one reason I like Eyewitness, and I tend to use it on internals. So how are we doing on time?
Jason, I think probably another 10 or 15 minutes or so, and
Okay.
been sharing a few questions in chat too, so if you have time to tackle those at some
Okay.
point.
All right. Okay, cool. Okay, so switching gears now. We've been talking about reconnaissance on a wide scope target and how an adversary will collect subdomains and domains they want to attack, right? And that's this is, I've lived in those adversary groups. They're absolutely doing it like this. And but then there comes a time when you stop doing wide scale recon and you do a different type of recon. It is analyzing usually a web application, and that's my specialty. And so part of the things we teach in the course is a section called app analysis and how to break down a web application into places where vulns might be. And so this is really useful for those of you who might have been doing a lot of, web challenges. Now, when you're doing web challenges as part of CTFs, the CTF designers can only make those applications so big because of time constraints and just like they're not going to make a whole enterprise type site, just for a CTF competition. It might look like it, but they're relatively small by terms of URLs, parameter counts, and dynamic functionality. When you get into the real world, when you get a job testing things as a pen tester or red teamer, in fact, my first site was Salesforce, and this was a long time ago. So Salesforce wasn't as big as it was now, but it was still huge. Salesforce as a web application has like 7 different APIs that APIs get the API calls build dynamic views and get data for them. Hundreds, if not thousands, of parameters that you can pass data through. Hundreds of forms where you can pass data through. It is a giant machine of a website. And so when you're doing real world testing, a lot of people who come from another discipline, like another world, or students who come out of college or something like that, they get their first web assessment and they're like, oh crap. Like all the CTFs I've ever done usually are these small sites that I can pinpoint where the vulnerability is and usually guess at what it is. But this site, it's totally different. I have thousands of things to check. How do I, break this down into, kind of a mental model where I can attack like a big site? And so this part of the class is talking about some strategies for that. I guarantee you I won't get through all these slides. So I will give the slides to the organizers and you can look at, obviously everything in there and then find me somewhere we can chat about, something if I don't get to it. But these are the big questions I ask when I'm looking at an enterprise level site. Usually it's 6 or 7 questions. How does the app pass data? How and where does the app talk about users? Does the app have multi-tenancy or user levels? Does the app have a unique threat model? Has there been security research and vulns in the past? And how does the app or framework handle specific vuln classes? Now, this is for web testing. So, passing data. It's really important because when you're fuzzing for web vulnerabilities like, server-side template injection or server-side request forgery or SQL injection or cross-site scripting or, whatever you're looking for, normally you're passing data into the application. And there's 2 ways to do this. There is the old school way, which is the resource value or resource parameter value format, which looks like this. It's like your app slash resource question mark, then your parameter, which is where it's a function basically, and data you're passing into it after the equal sign. And then if you want to pass, multiple functions or the same function, multiple pieces of data, you add an and sign and then you do it all over again. This is the resource parameter value format. Now, if you're testing these websites, you're normally going to inject your test cases or your fuzzing payloads after the equal sign, where this value is. That's normally where you're going to do your testing. Every once in a while, you'll get an edge case where you can pop a vuln by doing something with the parameter name or the resource name, but not very often. Most of the time, your vulns are going to end up you testing in this space right here. Now there's also RESTful format, which it looks like this, like app.com/route resource sub resource, possibly data, whatever. And so in this way, it takes a lot more time to, especially with enterprise applications that have these super long URIs or URLs. In this format, in RESTful format, it's you actually have to guess at what the resource and the sub resource is and where the data is being passed. And so this is the first question you have to ask yourself when you're looking at a site because it will dictate where you test and how you test. The next question is how does the application talk about users? Where does it reference users? Is it just like a normal web architecture where every user logs in, they get a cookie, that cookie is hopefully protected, references their session ID, and then when they visit the site, the server checks the session ID and gives them the appropriate data and fills out the UI. Is that, what you're looking at? Um, does it do that via methods of like, old school kind of that resource value resource, does it pass the data via like an API or, one of the old school methods? And then the next question I ask is, okay, so most sites will be like that, where you have a cookie that references you. But now you want to start looking at the application and using it like a power user, right? Like walking the app, using all the features and stuff like that, and to see if there's any other place where a UID is mentioned, an email address is mentioned, a username is mentioned, or a UUID is mentioned, because that means that they're referencing a user outside of this normally controlled and very standard workflow. And so if you see these referenced and it's your user ID or your email or your username, that's a place where you want to try to inject somebody else's UID or somebody else's email or somebody else's username to try to find an access or authorization or logic bug. And this is one of my specialties when I hunt on big applications. You would be surprised how often you can find these vulnerabilities if you break it into this mental model. So this is the next question that I ask. The next is user levels. So not only are you looking at, the previous stuff on the last slide, but you're also asking yourself, was this app designed for multiple customers and multiple user levels? And so you want to do vertical testing of, let's say, you log in this application, you use it as a power user, and you have like a certain level account. You're like a account viewer, right? But there might be other levels of access, like account admin or admin of the whole framework, or you might be unauthenticated. You have to map out how this application works and check to see if the unauthenticated user could maybe access based on lack of authorization, an account user, an account viewer, an account admin. This happens all the time as well. And so testing vertically and horizontally for these access bugs is a big part of in-depth web testing. And a thing that a lot of people it takes a little time for them to get used to mapping this out. Now, there are tools to help you do this. You can, DM me on Twitter or something like that. I'll tell you kind of what we use. We use a lot of burp tools to do this, burp suite, but this is a core question that I ask in the workflow. The next one is, does the application have a unique threat model? So many applications, handle special data. And, so Twitch, if you've ever streamed before, that there is like your stream key, and it is like a master API key for your whole Twitch world, right? Like if someone gets a hold of your primary stream key, then they can impersonate you. They have access to all the data that Twitch, has in your account, everything. So protecting this API key in the UI is really important for Twitch, and it adds another piece of targeting that I want to do when I'm testing this web application. Not only do I want to execute cross-site scripting, but I want to execute cross-site scripting against Twitch so that the JavaScript can steal this stream key and send it to me, the bad guy. And so asking yourself, is there some kind of unique threat model that this website has or this application has won me more web tests than I can really mention. The other question is, has the site has previous security research? I always go when I do some Googling on the domain that I'm looking for, and I start asking Google, I'm like, hey, has there been any XSS vulnerabilities on this domain before? I go check the bug bounty platforms. They each have feeds. And so, if I were looking at Tesla, Tesla has a bug bounty, and you can go look at all of the disclosed bugs that they've had. If they choose to disclose them, they have to choose. But you can see stuff like there was a post message XSS in the payment portal. There was an issue in their forums.tesla.com with DOM XSS. And although these have been remediated, there's always regressions in code, and there's always ways that customers try to patch these things like XSS or server-side request forgery or something like that. And normally they do it really poorly. They will rely on a very brittle regex to block an attack or something like that. They will blacklist the individual attack string. They won't actually at a core level fix the vulnerability many times. And so testing for bypasses to an original fix is very lucrative. You can find a lot of regressions or, like half regressions. And that's why I asked this question of when looking at sites. The last is finding out the framework that they're using. So, and just finding out, what does the framework do for them? Does it protect really well against vuln like cross-site scripting or CSRF or something like that? Does it by default have enabled input validation and output encoding, which are the two biggest things that you need to do for a web app as far as security goes at the framework level? Are those turned on by default? How would I know? And so I just go do some research about the framework itself. So here I'm looking at Laravel, and I want to know how it protects against XSS. So I'm just going to do some Googling and spend some time understanding the framework that their web application is built with or around. Um, and it helps me in my hacking. Um, Another thing to think about is when they have these frameworks and they do implement the configurations to have good input validation or output encoding or mitigate certain vulnerabilities. At the framework level, that's cool, and most forms will be protected from that. Most API calls probably will be protected from that. But then you have to think about where, if they enabled that, would that not work? Where can't these protection works? And so a lot of times there are pieces of your application that you develop as an enterprise that you bolt on. And so things like a WYSIWYG editor or a webhook integration form. If you put attacks in a webhook integration form or WYSIWYG editor, by their nature, people don't want that to be messed up by output, encoding sometimes, or transformed by any like security function or middleware or anything like that. And so you have to ask yourself, like, where is it harder to implement that protection? And these are two places that it's harder to implement that protection. So I have a hit list for this later. By the way, webhooks usually always vulnerable at some level at the beginning of their development to SSRF. WYSIWYG editors usually always vulnerable to some form of cross-site scripting. Okay, so data storage is one of the last questions. How do they store data that I upload? Is it to an AWS, S3 bucket or an Azure blob, storage or something like that? If I feel like it's not being stored like that, is it going directly to the server? I want to know where the data exists, just so that I can either attempt to go hack that place or understand if I upload a file or some data, maybe it's an inroads for a vulnerability. So I have to ask myself, like, if I'm looking at this application, where does it store data? Okay, so those are the big questions, and then I move on to heat mapping. I'm going to blow through this really quickly. Okay, so heat mapping is the idea that an application has places that you want to go rather than vulnerabilities you want to find. And this is just based off of 20 years of web testing, right? Okay, so places where it's harder to secure are places you want to focus on as an attacker. So things like headers, harder to add security protections to data that comes in that you're processing from headers or from file uploads or from URL handling in things like webhooks or any place that you let the user give you a URL. Really hard to secure these things out of the box. Any type of new functionality as an attacker, if there's a new feature or a redesign of a feature, I am focusing there as a hacker because probably not built by the original team, may not have turned on the security features or protections that the rest of the code has applied to it. So really interested in that. And then any feature that's gated. So let's say you use a website and there's a free version, but there's also a paid version. I will pay the money to get access to a site to get access to features that are paid only. They have had less eyeballs on them from a hacker point of view, and usually have had less security testing on them. And so I will pay money, sometimes hundreds of dollars, to get paid account access to get more surface area than the next bug hunter. And then admin functionality. I will find the framework admin functionality and test the hell out of it to see if there's any misconfigurations, because that usually leads to gold. So these are things that are like gated either by access or by money. File uploads, definitely a place you should look for. I'm just going to go through it super quick. So any file upload that allows you to integrate to a third-party site, you can try to ingest XSS strings. Any self-uploads, things like documents, you can look for server-side request forgery, cross-site scripting, and external entity ejection. Anytime you can upload an image, you can try to shell a server with adding shell, like, basically whatever the server-side coding language is. You can add code into your images as the name, as the binary header, or as the metadata in the file. This is older. This doesn't work too much nowadays. I find it mostly on internal applications. And then if data is stored on S3 via uploads, you just want to check for S3 permissions and make sure there's not open access. Content types. Anytime I see a multi-part form, I'm looking for shell injection or like local file includes or SQL injection in multi-part forms. Anytime I see content type XML in my proxy, I'm definitely testing for XXE. And anytime I see content type JSON, I'm just going to do a whole API assessment because usually it references, an API. APIs. The big hits for API hacking are hidden methods that you can find by fuzzing, and then lack of authorization on admin functions that you find in the API. These are the quick hits. If you want to go into hacking APIs, which is a large section of web hacking these days, these are probably the two best print resources you can check out: Black Hat GraphQL and Hacking APIs by Corey Ball, and this one's by Nick Alex. The account section, anytime you can put stored data in an application, you should be looking for stored cross-site scripting, server-side template injection. Anytime you have an integration with a third-party site, you should be looking for server-side request forgery and cross-site scripting. And then anytime you receive errors through your proxy, like Burp or Zap or whatever proxy you're using, you just want to look at them and try to understand why the error was elicited, and see if you can repeat the request that caused the error, and see if you can get like an application level DOS, or you can find some type of exotic injection. And then anytime the application handles a URL or path, you want to look for a redirect vulnerability, which can help you later on to get an account takeover, or a server-side request forgery vulnerability. All right, I went through that super fast. That is like, many more hours long of content in the real class. The real class is called the Bug Hunters Methodology Live. And if you want to reach out to me, this is my contact information there. Hopefully that was useful. So,
Jason, that was phenomenal, absolutely phenomenal, and super practical. I've been kind of bouncing between Discord and Brella, looking at some chats. Folks have been loving it.
awesome.
Love learning about new tools. Clearly, you're a trainer, you're a hacker, you know it all, and you have a great style to your presentation. So, thank you
Thank
for
you.
your professionalism in that. A couple of questions did come in. If you have just a few minutes,
hmm
maybe two or three, if that's okay.
hmm
Um, One of them, since the Microsoft Exchange APIs are being actively exploited, is there a way to decrease the attack surface or scope other than not using Teams?
Um, so it's mostly the Autodiscover services are mostly for desktop apps that are installed on the laptops or desktops that need to connect to them. So it's kind of the architecture that if you're going to use the Microsoft ecosystem for email or for Teams or any of the associated services, there hasn't been a real great way for them, at least, to mitigate that. I don't even think that on the blue side, there's a configuration that once you host a tenant, that like tenant IDs are placed all over the Microsoft Azure ecosystem or the Entra ID ecosystem. It's really hard to keep your tenant name and ID from leaking in one of the APIs. So as far as I've seen, no, there's no like configuration as a blue teamer that you can do to keep out of that if that's your ecosystem. I wish there was, and other architectures. So like the Google architecture, like Google Mail and Google Workspace and stuff like that, is not subject to the same thing. They don't have the same kind of thing because they're all web software, right? But people who have installed software who need to connect to the web services, like at some point, some domain information needs to get passed, and so that's just kind of the architecture right now.
Awesome. Um, there's a couple that I'm gonna come back to
Okay.
just because they're a little bit more about you and your company specifically.
Okay.
Can Jason give an example of a bug bounty where GitHub leaks were essential to the strategy?
Uh, yeah. So the story I skipped over was I was at a conference called Hack SpaceCon, which was in Florida, and it was at Kennedy Space Center, which was super fun because there's like rockets there and stuff, and I'm a giant nerd. And so the NASA director is there, and I'm doing a version of this talk where I talk about GitHub hunting, and I spent much longer on it. And so I did a live demo, and I said, "Hey, does someone want to do a domain where we can look up, some GitHub dorks?" And so live on stage, I found several hard-coded keys from NASA employees hard-coded into GitHub right there on stage, and had to cut short a little bit so that I didn't dox them. Now, one ended up being a false positive, and two ended up being valid. So yeah, absolutely. I found tons of stuff. I found a big auto manufacturer. Um, this one was crazy. Okay, so testing a huge auto manufacturer and ran the CheckMDI tool and found a really weirdly named domain that wasn't their normal name. And I was like, that's really interesting that there's like, this is randomly named. So I go look that up in GitHub and do some GitHub dorking on it and find some references, leads me to a file that has a whole bunch of their domains, some that I had never seen before, to set up some type of integration script. I can't remember what it did. Anyway, so now I have a list of new domains. And then there's another one I haven't seen before. I hadn't seen it through CheckMDI. I hadn't seen it anywhere else. So I just go to it, right? I go grab this domain, put www in front of it, and go to it in a web browser. It is a Confluence and Jira ecosystem that they had stood up. And so after basically poking around in it for a long time, uh, it ended up that this company, this auto manufacturer, they had a set of developers who the organization wouldn't let them use Confluence and Jira. And they really wanted to use Confluence and Jira. So they stood up a new domain, didn't tell anyone in IT, and had a whole ecosystem of Confluence and Jira that they were using outside of the organization that nobody knew about. And of course, they had multiple issues in it because it wasn't fully up to date and patched. It was self-hosted, and default creds, and some configuration issues that allowed me to read tickets. And so I just pillaged the hell out of this thing. And the report was basically like, yo, your devs stood up this thing. I don't think you know about it because I've never seen it anywhere else. And they were like, yeah, we had no idea this existed. So that one was really funny.
Unbelievable.
Yeah.
Wow, that's probably not what they're wanting to read in the report.
No.
But great work. Um, all right, one of the last questions that I'll throw at you, you mentioned, I think early on, you were talking a little bit about your organization, Arcanum. Did I say
Mhm.
that right?
Yeah. Yeah.
Arcanum. And some use of AI. So some of the folks that are in the crowd were just curious kind of what the implementation or usage of AI looks like from your
Yeah.
perspective.
So I have a whole framework that I use, and let's see here. I'll kind of show you what it looks like. Let's see. So it's a Bash framework. It wraps a lot of these techniques in a Bash kind of framework modularized to do each thing one at a time. And so this is the kind of stuff I'm using AI for because a lot of these processes were manual before. And they were manual because you had to do a lot of like judgment calls on the data that you would return from these APIs and decide this is interesting, this is not interesting, or I need to take this kind of output and with my 10 years of domain knowledge, understand that this thing is important. And so you used to not be able to do that with a lot of scripts. But now with AI, you can. You can prompt engineer very good logic saying, these are the things that I key in on. And if you see it in this data set, alert me. So I built a modularized framework to do a lot of what we just, talked about. It's called ArcBot. It's named after my daughter, whose name is Arcadia. You can just start a project here. So I'll just do like Tesla 3. You can put in, domains or ASNs if you already have them. So you can just say like yes, and then you can just be like tesla.com, and you could put in an ASN here. And then it can do automated ASN discovery with AI. So this is a module that will attempt to pull from APIs, parse the data, as well as look in the model training set for AI ASN discovery. I'm going to say no right now in the episode time. You can do the check MDI scan, which it grabs. You can add all these to the project. And then you can do a whole bunch of other modules. Reverse who is, which I didn't talk about in this, that Caduceus SSL inspection. You can do domain discovery via the OpenAI API to their models to see if it's in the model training. You can do acquisition discovery through AI now, cloud recon through AI, subdomain enumeration. This is still manual. Um, and then finding web servers and stuff like that. This is still manual too. And yeah, so I've built my own framework to do all this, and like half of these modules are now AI enabled, which makes them infinitely better. Now that's for the recon stuff. In the web testing stuff, I use AI all the time to build those cases, those permutations of attacks to try to bypass brittle filters. That's a real big hit for me. Um, to understand JavaScript. I am not by any means a JavaScript master, even though I've been looking at websites for a long time, especially modern JavaScript. There's so many frameworks out there to keep up with. And so I use AI all the time to explain to me what the hell is going on in this semi-obfuscated JavaScript. There's a ton of places. If you want to get into how to use AI for hacking, especially web hacking, there was another conference really recently that I hosted called NahamCon, and they had a whole day on AI and how to utilize AI in bug bounty hunting. So, yeah.
So cool. Some folks asking about The availability of ArcBot.
Nope, that one's mine right now. Sorry.
All good. Fantastic. Jason, I think that's really kind of the end of the list of questions that I have seen. Um, Lots of clapping, all kinds of good
Awesome.
chatter. Um, Seems like everyone is very appreciative of you spending some time with us tonight. And hopefully, you all learned just as much as I did. I cannot wait to take one of your classes. Jason's handle was up there in terms of following him on Twitter.
Yep.
You're welcome to check out Jay Haddix. Some other contact information there as well. And certainly check out their website. They also have a virtual booth set up in Umbrella. So Jason, I can work with you guys and make sure that your presentation is tagged there. And if you want to make some slides available, we can put them up
Cool.
there too. Otherwise, folks, one last round of applause for Jason. Absolutely phenomenal stuff. Couldn't have asked for a better presenter to kick off Cyber Rush Week and our season 5 anniversary campaign series of events. So thank you from the bottom of my heart. It's folks like you that believe in our mission, believe in our vision, and make themselves available to give back to the community that really allow us to do what we do. So thank you sincerely from the US Cyber Games program for your time this evening.
Good luck to all the participants. Really appreciate the time too.
Wonderful. Thank you all so much for joining us tonight. We will see you back here tomorrow, 8:30 p.m. Eastern, 5:30 p.m. Pacific, for a talk on communication as a technical skill, as told by a cat, aka Stacy Dunn with Sands. So looking forward to that one. Have a wonderful evening, everybody. Thanks and take care.